Hi everyone. In this video, I'm going to explain what you mean by divide and conquer technique and how to apply divide and conquer technique in order to solve the problem. In my previous video, I explained about brute force technique. See, in order to solve the problem, there are many algorithmic design techniques are there. One among them is the simple and basic one is brute force technique. And we know when we are applying brute force technique. So we know that brute force technique can be applied only when problem size is small, simple and known. Okay. Suppose if the problem size is large and complex, then it is not possible to apply brute force technique. Then we need to apply other techniques. So other techniques in that, so now we are discussing about divide and conquer technique. So when we are applying divide and conquer technique, so if the problem size is large and it is complex, then we are going to apply divide and conquer technique. Now let us see what is the general plan of a divide and conquer technique. General plan means in general how to apply divide and conquer technique. Otherwise, how divide and conquer used to solve the given problem. So we call general method or general plan. So assume the given problem of size n. Assume this problem is complex and large. Okay, the given one problem which is of having size n, and assume that problem is large, so it's not possible to solve that. So what we will do, so in divide and conquer technique, so whenever the problem size is large, always we are dividing into two sub problems. Okay, so now I will get what? Sub problem of size. Okay, that means now here the given problem of size n, that I am dividing into how many parts? Two parts. So always in divide and conquer technique, we are dividing the problem every time into two parts, if the problem size is large. Now assume this is large, so I divided into two parts. So two parts means what should be the size of this each? So this is of size n by 2, this is of size n by 2, half. Okay, generally almost in equal parts we are dividing. Assume still these two sub-problems are still larger. So then what we will do, again I will going to divide these two sub-problem into further sub-problem. Okay, now when I divide this, I will get one more sub-problem of size how much? Now this is half. In this half, again I am dividing into half, means this is n by 4. Similarly now, so similarly this is also problem of size n by 4. This is okay. Again assume this problem is also still larger. Again I divide into two further sub problems, and all these sub problem of size n by 4. Now assume at this level, so I feel this problem is not that much large, we can solve. Okay, so assume we can solve this. Now we stop dividing. So whenever we feel it will be solvable, we will stop dividing. Suppose assume again still these sub-problems are still larger. Okay, then again we need to divide this into two parts, again this into two parts, like this. Each 4 sub-problems we need to divide into two further sub-problems. So we get in the next level 8 sub-problems. Okay, now here there is not mandatory that we need to divide into this 1 level, 2 level. So for some problems it may go to 3 level of 8 sub-problems of size each n by 8. Again in the 4th level of size n by 16 of 16 sub-problems, like it can go up to anywhere. That depend upon the problem size n. Okay, but in general, we keep dividing until the problem size becomes very, very small so that we can get the solution. Till that we keep dividing. Now in this example, now I will assume this will be small, we can solve. So once the problems are divided into sub-problems and sub-problems are further divided into sub-problems and this size is small, then we start getting the solution for that. That means now if I feel these sub-problems are smaller, now I'll get solution for this, I will get solution for this, I will get solution for this, I will get solution for this. That means we need to get the solution for all the sub-problems. I will repeat, we need to get the solution for all the sub-problems. Now assume I solved this sub-problem, I get the solution. Now this is the solution for what? This is the solution only of this sub-problem. But our intention is what? We need to solve this subproblem or this given subproblem of size n by 4. So our intention is to solve this subproblem, this problem, not this subproblem. So, but we solved what? We solved individual, all the subproblems we solved. So this is solution for what? This subproblem. So I will name each of the problems. Okay, assuming the given problem is of size A. Okay, assume the given problem of size n is, I will name this as what? A. I will name this as a B. I will name this as a C. I name this as a D. This as E. This as F. This as G. You can name whatever. Now what I got? Now this is a solution for what? Subproblem D. So solution for D. Now this is a solution for what? Subproblem E. This is a solution for what? Subproblem F. This is a solution for what? Subproblem G. Now once I'll get the solution for all the subproblems, we are conquering, that means we are acquiring the solutions. That's what, see, as the heading says, divide and conquer. Now division over now. Here division. This is the first step. Next is conquering the solution. Conquering means acquiring the solutions. Now we need to merge these two solutions, okay, to get what? Solution. Now if I merge these two solutions, so now I will get solution for what? I'm getting solution for this subproblem B. Similarly, if I merge these two subproblems, I will get what? Solution for this subproblem C. But our intention to solve these two subproblems or this problem, our intention is to solve this problem. So again, I need to merge these two solutions. Now this is the solution for given problem of size n. This is the solution for my problem. Now this is what the divide and conquer technique. Okay, so that means in divide and conquer technique, if the problem size is large, keep dividing the problem into subproblems or further subproblems until the subproblem size becomes small, or until we get the solution for all the subproblems. Once we get the solution for all the subproblems, then we need to combine those solutions to get the solution for the overall problem of size n. So this is what the general plan of divide and conquer technique. Okay, so hope you people understood this concept. Okay, so now with it, now we are going to derive the equation for the divide and conquer technique. Now here, how many subproblems finally we are having? See, finally 1, 2, 3, 4. At the last level, we are having 4 subproblems, right? So now assume to solve each of the subproblems, assume I am taking, to solve these subproblems, I am taking 10 nanoseconds. To solve same again 10 nanoseconds. Why I am taking 10 only same here also? Because all these subproblems of same size n by 4. So I am taking this also 10 nanoseconds, this also 10 nanoseconds. So totally to solve this problem, how much time? See, because this problem only I divided into 4 subproblems at the last level. So time taken to solve this one subproblem is 10 nanoseconds. So total time taken to solve all these 4 subproblems, what? 10 plus 10 plus 10 plus 10. So it is 40 nanoseconds. But instead of adding multiple times, now I can write what? 4 into 10 nanoseconds. So this is not about what? 40 nanoseconds. But so here this is what? Number of what? Subproblems, right? So here we are having 4 subproblems. 1, 2, 3, 4. And this is what? Time taken to solve. One subproblem. Correct? This is the time taken to solve one subproblem multiplied by number of subproblems. So I got 40 nanoseconds. Okay. This is what the equation. So now in general we need to write the equation. So in general the equation use this. So we know that what? T of n. T of n indicates what? T of n indicates time taken to solve the problem of size n. That is time complexity of problem n. So this is equal to what? So what is the time taken by this problem? Time taken to solve each subproblems. Okay. So now how many subproblems we are having here? In this example 4. But If I go to the next level, 8 subproblems. You can go to the next level, 16 subproblems. So we don't know. It may suffer some problems. It may have 2 subproblems, 4 subproblems, 8, 16, 32. It may go at anywhere. So in general, I will take a number of subproblems. Okay, in general, I will take a number of subproblems. And to solve one subproblem, I taken some time. So that I am writing as time taken to solve the subproblem of size n by b. See here, why I am taking n by b? Here it is n by 2. Here it is n by 4. Next level n by 8. Next level n by 16. Next level n by 32. Like it goes on. It never knows. So in general, I am taking as b. Here b decides the problem size. So t of n indicates what? So T of n indicates what? Time taken to solve the problem of size n is equal to A, where A indicates what? Number of subproblems into time taken to solve one subproblem of size n by b. So this is what we take written here. 4 into 10 answer. This is the number of subproblems, and 10 answer is the time taken to solve one subproblem. So that's what written. So this is number of subproblems into time taken to solve one subproblem. But we did only this one, but we also spent some time to what? Here to divide, again to divide, again to divide. To divide also we spend time, and to merge these solutions also we spend some time. So that also we need to consider. So that we can write it as, so f of n. So here f of n indicates what? So represents time taken to divide and merge. That means time spent to divide and merging. So that will be f of n. So this will be my final equation for to find the time complexity of any divide and conquer algorithm. So this is the time complexity equation. So we'll call this as the general recurrence equation to find the time complexity of any algorithm which follows divide and conquer technique. Hope you people are understood. So thanks for watching. So please write the comments if you have any questions. Thank you.